All that glitters is not gold. You must have heard this many times. What does it mean? Actually, if you take the case of any metal, whether it is copper, silver, zinc, even iron, you will find it glitters. Sometimes, due to exposure to air, the surface becomes dull. Rub it with some sandpaper or clean it with vinegar or tamarind juice or lime juice. It starts shining all over again. You see, the easiest way of classifying matter is into two forms, metals and non-metals. All around us we find that there are metals and non-metals. They are part of our life. We cannot survive without them. Your cooking utensils, made of metals. Your electrical wires, again made of metals. The jewelry women are so fond of, gold, silver, platinum, all metals. Not only this, non-metals are not way behind. Diamonds are forever. And not only that, carbon is a part of living body, every living body. Phosphorus is there, nitrogen is there, chlorine is there. All these are various elements that are around us, and if we want to classify them, the simplest way is into metals and non-metals. Now, how do we classify it? If I want to say that okay, I need tall boys for say playing volleyball. So, what do? At the basis of height, I will make two groups, the tall boys. Not that the short boys are not cannot play any other game, they can. Probably they will be good if we take say for example a game like football. It's all right, the strength is more important, the footwork is more important. But then height is not the only criteria. Just by height does not mean that only tall boys can play better games. You need agility also, you need stamina also, you need strength also. So, whether boys or girls, if they want to be sporty, they need all these things. Only then we can say whether this person is suitable for a sport or not. Similarly, when we want to classify elements into metals and non-metals, the criteria that we will use is physical properties. Physical properties means their appearance. So, just like I told you that the most visible and the most obvious property is that they glitter. So, that means all of them have a shining surface which is called metallic luster. Now, just now I showed you how we try and cut these metals. You found it was pretty difficult to cut metals like say iron or zinc, but on the other hand the alkali metals like sodium and potassium, they can be cut very easily because they are very soft and they are just like soap. So, we can say that metals are hard. Of course, except sodium or potassium. Thirdly, what we find is that metals, they are very good conductors of heat. How do we say that? You know, when you are cooking, if you use the serving spoons just like that or leave them in the pan, they become very hot and it becomes difficult to hold them. So, you must have seen that mostly the serving spoons are usually their handles are covered either with plastic or with wood. Why? Because plastic or wood is a bad conductor of heat. They do not get heated up. We need metal to make vessels because unless they get heated up, cooking will not take place. But the serving spoons have handles that are plastic or wood. So, you understand how we are utilizing the property of metal. This can also be shown by a simple experiment that if you take an iron rod, fix it on a stand, and on the extreme end we fix a pin with the help of a wax, and then we heat this at the other end. Obviously, after a little while this pin will fall down. Why? If we touch the other end, we will find it is hot, and as a result wax melted and the pin fell down. Now, although we were heating this end, how come it has reached this end? So, we can say that metals are good conductors of heat. And we have used this property by making cooking vessels. But now we can also see this, that all our electrical wires are made up of copper or aluminum. Why so? If we make a circuit, electrical circuit, what do we find it? That the moment we use copper wires, the bulb glows. So what does this mean? This means it is also a good conductor of electricity. Now you see, we use wires made up of copper, but invariably we cover them. Just like the spoons I told you have wooden or plastic handles, the wires are covered with plastic or PVC. Imagine if they were not covered, the moment we would touch them, we would get electrical shock. So obviously they are covered with something which is an insulator, which means through which electricity cannot pass, and it is safe for us. That is why the precaution is that no live wires at home, especially when there are small children, because if you will touch them, you can get electric current. So metals are good conductor of electricity, and this property has been utilized by making electrical wires. But then how they were changed into wires? Very strange. Now this is another beautiful property of a metal, that it can be drawn into wires. Very thin wires. You see, 1 gram of gold can be stretched into 2 kilometers of wire, a thin tube. Now this property is also used for not only making wires, but also making intricate designs of jewelry. So all the metals, they can be drawn into wires, and this property is called ductility. So metals are ductile. Now you take a hammer, take some metal, start beating it. It will become flat. It will not break, but it will become thin and flat. That is why we are able to have so many shapes of vessels, of decoration pieces, statues, because metals can be beaten into sheets. Now this property has also been used for making vessels, decoration pieces, statues, and what not, even the jewelry. So such a property is called malleability. So we can say that metals are malleable. How your school bell rings? The bell and the hammer both are made up of metals. And how sometimes you wish to hear that ring quite early if the period is boring, or if the next period is a games period. And the same ring sounds so nice to your ears when it is the final bell and the school is going to be let off. Now why only metal? Why don't we use any other material for making a bell? Once again, another property of metal, that when it is struck, it produces sound. That is why all the bells are made up of metals. This property is called sonorous. So metals are sonorous. So this is how we find that various properties of metals have been utilized for so many ways. Another property is that metals, here you have seen in all the cases, the metals were solids at room temperature. So, this is another property of metals, that they are solid at room temperature, except, I know this is what you were about to say, except mercury, which is liquid at room temperature. That is why it is used in thermometers. So, you can say solids at room temperature. Except mercury. Now, why we are able to make metals into cooking vessels? Don't they melt? No, they don't. Most of the metals have very high melting point and boiling points. Here again there is exception. Gallium and cesium, these are two which have very low melting point and boiling points. In fact, they can melt even on your palm. Just by the heat of your body, they can melt. Their melting point is so low. High melting point and boiling point, except and cesium. So, we find that these metals, they show these properties, but there are exceptions also. Now, if we just take up the properties of non-metal, we will find that they are a little different from metals. That is why we are able to group them. Now, the features of non-metals are, first of all, they are not solids only. They can be either solid or gas. Solids, example, carbon, phosphorus, sulfur. Gas, chlorine, iodine, hydrogen, oxygen. In a rare case of bromine, they can be even liquids. Example, bromine. Now, we say that non-metals don't have luster, but then what about diamond, which is a form of carbon? It has luster. Even iodine has, but generally speaking, no luster. Low BP and melting point, except diamond. Then they are brittle. That means they break. They cannot be beaten into sheets or drawn into wires. Not malleable or ductile. Not sonorous. Then what about heat and electricity? They are not good conductors of heat and electricity. Bad conductors of heat and electricity. Here also there is an exception. If you see the cells, they have graphite in them. If they are bad conductors, why are we using graphite? Because graphite is an exception and it is a good conductor of electricity, except graphite. So, we find that these are some of the very obvious differences between metals and non-metals.